step is step number 3. I need to calculate MdB values at two particular frequencies in the lower end, which means at omega L, which we have assumed which is the frequency lesser than the lowest corner frequency, and omega C1. At these two frequencies I want to find what is the magnitude value. Remember, for these two with these two frequencies and corresponding MD values, I can draw the initial slope of my magnitude plot. To draw the initial slope, we need 2 points, and those 2 points coordinates will be, one is omega L and corresponding MdB value, omega C1 corresponding MdB value. I am going to calculate those two. So to calculate those 2 points, because omega L, omega C1, these two are available. What are the y-axis terms? MdB for omega L, MdB for omega C1. I can use the first term. The first term is related to the initial slope of the magnitude plot. The initial slope, how it is coming. So the initial slope is related to the first term. Let us take the first term. So we know the for first term it may be either k into s power n, k by s power n. So if at all it is k, then what will be the magnitude MdB? It is 20 log k, means the slope is 0 dB. So at omega L we have one particular value, at omega C1 also one particular value. It is a horizontal line which is parallel to my x-axis, log omega axis. And when k into s power n, the first term is k into s power n, MdB equation we know 20 log k plus 20 n log omega, and this equation we can take it. Then in place of omega I will substitute omega L first, get what is MdB omega L. Then the second case, in place of omega I will take omega C1 and get what is MdB omega C1. Therefore I have MdB for omega L, MdB for omega C1, and also I have omega L and omega C1. So this information we will find in this step using the first term of the transfer function. In fact, the first term is also available in the table in step 2. Then step 4. So in this step 4, for other corner frequencies and also at omega h, I want to find MdB values. So omega L we know what is MdB value, omega C1 we know what is MdB value using the first term information. Then for other corner frequency, let us see how to calculate. Now we have one formula there, we can use this formula and we can get very easily corresponding MdB values for any omega C2, omega C3 and so on up to omega h. So this formula is derived from the initial we have the slope is equal to MdB2 minus MdB1 upon log omega 2 minus log omega 1 dB for decade. So in that the unknown is MdB2. MdB2 in this case is MdB omega C2. First one, MdB omega C2 is S omega C1, that is the slope which is there in the table. Take that S omega C1 value into log. This log is always base 10 and omega C2 by omega C1 plus what is the previous magnitude? The previous magnitude MdB at omega C1. So MdB is omega C1 we have value, and this also we can calculate using omega C2 and omega C1. Then you can find out what is the MdB value at omega C2. Similarly, let us say MdB at omega C3. If you want to calculate, we have to look at S omega C2, slope at omega C2 into log then omega C3 by omega C2 plus MdB omega C2. So this way we can calculate for all the corner frequencies and also omega h. Then we can prepare a table. So this table, as I said, it consisting of omega values and MdB values starting from omega L, omega C1, omega C2 and so on up to omega h and corresponding MdB values. Now take the plot, magnitude plot. So in this magnitude plot, take appropriate scale depending upon the frequency range which is available in the table and locate the points. So we can also take the y-axis proper range, x-axis, y-axis proper range we should take and locate the points. Once all the points are located, we can draw the straight lines, because whatever the plot we plot, that is the asymptotic plot or it is the approximate plot. Therefore, we draw straight lines between the points, which is nothing but my magnitude plot. So once the magnitude plot is available, the next step is a phase plot. What are the steps to be followed? In this case, we have a single step, because once gh of s is available, we can write s is equal to j omega, that is gh of j omega, sinusoidal transfer function. Then you can write down the phase angle expression. For all the terms, we write the phase angle expression and have that phase angle expression. Then you prepare the table. And what is this table? This table consisting of again omega and corresponding phase angle in degrees. And what will be the range of it? So this range depends on the previous magnitude frequency range. So depending upon that, choose properly omega values and substitute this omega value in the phase angle expression. Find out all the angles in degrees. So when you are doing so we should compulsory take the points corner frequencies in the omega range. And also, whenever the phase angle is changing around minus 180 degrees, you take more number of values around minus 180 degrees of here. So because if you do that, then the plot will be very smooth and you will get the values very accurately. This is a phase plot. So we need to draw the magnitude plot, phase plot on the same graph sheet for the analysis purpose. So we can calculate all the domain specifications and also can find the closed loop stability, and the same can be used because in design we are going to modify either phase plot or the magnitude plot. When you modify, the modification is also should be plotted in the same graph sheet. So when you take the graph sheet, a lot of things we need to draw, and therefore choose the proper scale before plotting it and locate the points. Then we can plot the magnitude plot, the straight lines, whereas the phase plot you draw a smooth curve, because we have more points in phase plot, we can draw the smooth curve for the phase plot. So these are the steps to be followed for magnitude and phase plot to draw the Bode plot.